All right, great, thanks. So the general topic of this project is software learning, or how we can help people gain the skills they need to use complex software applications. And some of the foundational work in this topic took place in the late 80s and early 90s because the world was grappling with this new technology of personal computers. And an early result was that when learning software, people have a production bias. They just want to get their work done. They don't want to spend dedicated time on learning. And they have an assimilation bias. They apply what they already know to interpreting new situations. And so at the time, this was used to argue for training systems that allow people to learn in the context of realistic tasks and relate software concepts to the non-software world. And this is a really powerful idea. But now, 30 years on, a whole lot has changed. From a young age, kids start playing video games, using simple apps, and then moving on to the more sophisticated software required by their careers and creative endeavors. And so this raises a really interesting question, which is, how can a user's experience with existing software applications be used as a foundation for expanding their knowledge into new and unfamiliar software and domains? And there's been some work in the past in this vein. So the Show Me How system at UIST 2011 looked at automatically creating these mappings between the terminology in multiple applications to kind of relate concepts and help people find equivalent functionality. In this work, we kind of build on that and take a bit of a different approach. We're interested in developing what we call cross-application bridges that start with the interface of a familiar application and then just gradually change their interaction model, tools, conventions, and appearance to resemble that of an application being learned. So the idea is to avoid this experience where you're dropped into a new application and suddenly even the basic stuff is hard. You kind of are getting oriented. Instead, we want something like the chart on the right, where you gradually introduce features and you make this transition over time. And so to investigate this idea, we developed Blocks-to-CAD, a cross-application bridge from Minecraft-style building games to 3D solid modeling in Tinkercad. And so the user starts in a game like this, and then eventually they wind up using more and more Tinkercad features until they're doing stuff like this. So just as an outline of the rest of my talk, I'll discuss some related work and the design principles we used for Blocks-to-CAD. I'll walk through the system's features in detail, and then I'll present the results of a user study we conducted with kids ages 10 to 14 that showed this system can effectively help them learn Tinkercad. So in terms of related work, there's the Show Me How system that I discussed already, but this work is also related to training wheels for user interfaces and multi-layered interfaces, in that we're progressively revealing interface functionality over time, and adaptive interfaces in that the system's initiating these changes. But in contrast to these two areas, we're using these techniques to bridge multiple applications, to fade from one application to another. We're also informed by prior work on using games for learning, such as Dong et al.'s work on discovery-based games and Bruckmann's design recommendations for educational games. And so we had three main design principles for Blocks-to-CAD. We wanted to build on the known application, gradually transition between interaction models, and present new capabilities in motivated learning scenarios. And to work towards these, we started by taking a really close look at the similarities and differences between Minecraft and Tinkercad. So at a high level, both of the applications are concerned with building in 3D, but that's kind of where the similarities end. In terms of application domain, you have a sandbox game on the one hand and a 3D design tool on the other. In terms of data representation, you've got blocks, this sort of voxel grid representation, versus a collection of solid 3D primitives, kind of in a graph structure. And then the interaction model differs in a whole bunch of ways. I mean, the most drastic one is that Minecraft has a locked cursor. You don't have a cursor, whereas in Tinkercad, you use a cursor to interact with toolbars and buttons and objects. And then finally, you've got first-person 3D navigation walking around versus object-centric 3D navigation, where there's a pivot, you do panning and zooming and all of that. So these are some really major differences, and so we decided to use a multi-step approach in our system. So initially, the user can walk around the world and create or remove individual blocks in one of 6 colors. But then as they work, the system's monitoring what they do, and if they build tree-like structures, a tree stamp tool is introduced. And so when it's introduced, it opens a little video thing that gives a short 10 to 15 second video introduction to the functionality. And then it's added to your kind of toolbar at the bottom. And then when they use that command, it kicks them out to a third-person mode where they can then stamp trees. And the key thing here to notice is that this tool is saving them time, so that's adds some motivation to use it. But also it starts to introduce working in this third-person view with a mouse cursor rather than in the first-person mode. Use of that tool gradually unlocks 3D navigation widgets, which match those in Tinkercad. These are also introduced with a 10 to 15 second short video. I won't show those for everything, but this starts to deepen the knowledge of how to use this third-person perspective with a mouse. The next tool to be unlocked is a Shapes tool, which allows the user to drag 3D primitives into the space. And then these are converted into voxels when the player switches modes. And so the idea here is to introduce the data representation used in Tinkercad, and specifically to kind of introduce the differences between the data representations. In response to building kind of these tall stack structures, the system provides a capability for resizing the primitives using different handles. And then finally, based on use of the previous tools, the work plane tool is unlocked, which enables the placement of 3D shapes on the faces of other 3D shapes. And so at this point, when you look at it, this person is basically doing 3D modeling in the interaction model of Tinkercad. And so the features I've just shown are unlocked based on a set of heuristics applied to the content that the user is creating in the world and the operations that they're performing with the system. And the idea behind these heuristics was to try and unlock the features in situations where the newly unlocked features would be appreciated. So the tree tool gets unlocked if the user has created some tree structures as detected by a heuristic. You can see the paper for the full details on how the heuristics work. So finally, in terms of the details of implementation, the system is a mashup of the code bases of Tinkercad on the one hand and an open source voxel game engine on the other, with a whole lot of duct tape code to kind of connect the two. Both applications are built in JavaScript using the 3JS library, which would make it seem like, oh, this will be simple. But actually, you have to resolve a bunch of differences between libraries and get the wiring right so that they're all doing stuff in the same 3D scene. And then the other big challenge is input handling, because both applications assume that they have dedicated access to mouse and keyboard input. So that's a real pain to get working. So to evaluate the system, we conducted a user study to answer two main questions. The first was, how will users react to the unlockable features? Will they see them as this sort of ploy to like wedge learning into their fun game? Will they use them at all? That sort of thing. And then second was, will use of the system translate into improved skills in Tinkercad? So the study was a between subjects design. Half of participants used the full Blocks-to-CAD system with all unlocking enabled. The other half used the system with unlockable features disabled. So basically, they just had the basic block tools. And in an initial game phase, they had 25 minutes to create as many parks in the game world as possible, where each park had some rules. It had to have some trees, some shapes, a tower, and a house. And the idea was that in creating these parks throughout the game world, it would mimic them just sort of naturally working in Minecraft. This was followed by a 25-minute transfer phase where participants were asked to perform 3D modeling tasks in Tinkercad, the 3D modeling tasks that you see here. This is what the transfer phase looked like. They were editing in Tinkercad. So we recruited 12 participants, ages 10 to 14, with experience in Minecraft, but no experience in Tinkercad. Okay, so what did we find? First, I'll discuss sort of general reactions from the game phase among the experimental participants, and then I'll go into the transfer phase. So here's a timeline for the 6 participants in the experimental condition. And the red dots indicate when new features were unlocked, and the blue regions indicate time spent in the third-person mode. So what you can see is that all but one participant in the experimental condition unlocked all 5 of the features, and near the end of the session they were quite heavily using these. So given the chance, this is encouraging. People do use the tools. Participants also rated the unlockable features high on being useful and fun, and low for being annoying and disruptive. And this kind of matches what they told us at the end of the study as well. Between the 2 conditions, we didn't see a difference in ratings of fun or cognitive load, which suggests that the added features were not detracting from the game experience or making it significantly harder or more complex. And then finally, for the transfer tasks, participants in the experimental condition spent less time on average on the tasks, though we didn't find this to be statistically significant. Qualitatively speaking, though, we observed that participants worked differently on the transfer tasks in the experimental condition. So none of the participants in the control condition used the work plane tool, for example, whereas all but one used it in the experimental condition. And that one was the participant who didn't wind up unlocking it in the initial game phase. So just summarizing our results, participants did use the unlockable features when available. The added features didn't reduce enjoyment or increase cognitive load and were viewed positively by participants. And participants were able to successfully apply the skills they learned to tasks in the full Tinkercad interface. So overall, this appears to be an effective approach for teaching Tinkercad skills to Minecraft players. So a big point for discussion, I think, is what if we wanted to apply this cross-application bridges approach to other applications? And in the process of building the system, we kind of came upon a whole bunch of different strategies for designing cross-application bridges. And I'm not going to go through them all, but a lot of it comes down to a careful analysis of the differences between the interaction models of the 2 applications, and then using that to guide and create these motivated learning scenarios. For example, using these commonalities between the data representations and the advantages of each to motivate features that help users kind of discover how they differ. And in the paper, we discuss how you could kind of apply a similar approach to bridge Tinkercad to more sophisticated 3D modeling tools like Fusion 360 or SolidWorks. And a really nice thing here would be if you could get that developed, then in concert with Blocks-to-CAD, you'd have kind of this smooth path from playing Minecraft to Tinkercad and then up to, sophisticated software that people could use in their careers. So there's a few areas for future work that I just want to call attention to. The first, as I mentioned, is generalizing to additional applications and domains. A second one is more sophisticated user modeling and unlocking heuristics. So we used a set of basic heuristics that worked well for the study scenario, and we think that the overall idea of looking at content created by the user and the operations they perform is kind of a good approach. But you could imagine more sophisticated heuristics that use machine learning or ones that unlock kind of custom tools based on the types of objects or classes of objects that people create. So that's a really interesting area. And then another really interesting area would be to try and encapsulate some of this in a toolkit to create cross-application bridges. And I think that this could work particularly well for web-based technology where ultimately everything comes down to manipulating the DOM or WebGL canvases or that. So you do have this kind of common representation. And then finally, it would be great to do studies with other groups of participants. And we looked at kids because they were a natural group for Minecraft and Tinkercad, but it would be great to look at older participants and other groups as well. With that, I'll end, and I'd be happy to take questions.
Hi, I'm Leah Alba, Carnegie Mellon University. Curious, do you think this can extend all the way out of software into the physical world?
Oh, that's really interesting. Yeah, I mean, sure, why not, right? I think it would be really Yeah, I'm just sort of, I haven't thought about that at all so far, but I think it would be fascinating if the software at one point says, okay, now stand up and, grab a couple of 2x4s and do this or that. So, super cool idea. Yeah.
Cool, we should talk.
Yes.
Hi, Dan Ashbrook, University of Copenhagen. I'm curious what you're thinking about this being used in a kind of naturalistic setting, because during your study you had a setup that was kind of intended to push the participants in the direction of modeling Tinkercad, but in a quote real world scenario, would the purpose of this be for them to learn Tinkercad through Minecraft, or would they kind of be playing Minecraft and gradually just by chance learn Tinkercad? Or
yeah, I think that when we developed it, the idea was something like that, like a quite gradual transition over time. Obviously, for the study, we kind of tuned the heuristics and we set up the study conditions so that people could kind of go through the experience in 30 minutes. Ultimately, the idea would be it could be a longer-term process. And I think a nice thing about that is it would give people time to absorb each of the features a little bit more fully before the next one came at them. I think the big difference would be in tuning the heuristics and the specific heuristics that you use. And then that thing that I'd mentioned about, having heuristics that are based on the specific personal things that you create could play a particularly important role in that sort of a setup.
Yeah, thanks.
Really awesome presentation, thank you. I'm curious if you established a baseline to compare your user testing results to.
Yes. So when you say baseline, can you explain that just please?
Thinking about it in the context of how fast would a typical user discover these features, comparable features, in something like AutoCAD without your software?
Yeah, no, that's a really good question. We did not run a study like that. I think that one thing that I'm not sure if I mentioned in the paper, but I think that compared to a straight-up tutorial on using Tinkercad, a straight-up tutorial on Tinkercad would probably be faster to get people up to the same level. I think that the real benefit here is that if somebody is not necessarily going to take the time to do a tutorial, then this sort of thing where they kind of gradually learn over time could help them kind of keep their motivation up and still get them to the same place. But I think it's an important area for future work.
Thank you.
Thanks again.
Yeah, actually, I had one last question, but maybe we'll save it for later.